Hey, sixth grade, welcome to today's video tutorial. Today we're going to discuss Chapter 3, and Chapter 3 is Algebraic Expressions and Properties. And the first section is titled Algebraic Expressions. All right. Our learning target for the day is I can evaluate algebraic expressions. I'm just going to abbreviate that. Okay. A lot of times when students hear algebra, they really think of letters and solving for something or finding x. At first, when we introduce it, when we talk about expressions, you don't solve expressions, you evaluate expressions. And we'll talk about what that means and exactly how you do that today. I'm going to have some new vocabulary this section, and I also have a model for us drawn that will be really helpful. So first, we'll start off by saying an algebraic expression is an expression that may contain numbers, operations, and one or more symbols. The different parts of an algebraic expression are called terms. Okay, so before we've talked about numerical expressions where we've just had numbers and operations, like 4 plus 3, that would be a numerical expression. Now we have algebraic expression where we might have numbers, operations, just like here, but now we introduce some symbols, okay? And let's take a look at a model so we can define a few more things. Here is an example, 5p plus 4. All right. Another vocab word that we have is a symbol that represents one or more numbers is called a variable, because that number can vary. The root word there is vary. So it can change, in other words. Okay. A lot of times, the most common that you'll see used in algebra is x or y. Mathematicians often use those two. And in this case, I'm going to point to that. Our variable in this example is p. Okay, maybe you want to put in here letter because variables are in math expressions are letters. And it doesn't matter what letter it is. Like I said, a lot of times they use x or y, but they can be different things. Okay. The next vocab word you have is a coefficient. So the number that contains the variable is called the coefficient. Okay, so coefficient, coefficient. I usually just say that this is the number in front of the variable. Okay, so the coefficient here would be 5. There are 5 p's in this example. Okay, remember that multiplication is the same as repeated addition, so that's the same thing as p plus p plus p plus p plus p. 1, 2, 3, 4, 5. Okay, that's the same thing as putting it this way. It's just a little bit quicker and easier to write it that way. And lastly, a term without a variable is called a constant because it never changes. In this case, our constant is 4. This number is always 4, and it's never going to change. So your constant, I like to just say, is just a number. That's how I like to think about it. All right, so we're going to be looking at different parts of algebraic expressions and saying, okay, this is the term, this is the coefficient, and this is the constant. Let's try that for example 1 here. Okay. Terms, well, to find the different terms, to find the different parts, I split at your addition sign. So in other words, here I have two terms, in other words, two parts to this expression. It's kind of like how you'll have different parts of sentences in English. In math, you can have different parts of expressions. The two terms that we have here, the first one is 5x, and then the second term is 13. We have two terms. Okay? And similar in letter B, I'll just abbreviate here, our terms, are separated at the addition sign. So our first term is 2z squared, comma. Our second term is y, and our third term is 3. Okay, 3 different terms in this one. You could have expressions with 4 terms or 5 terms or even more. Okay? Next, the coefficient, if you remember, is just the number in front of the variable. In this case, our variable is x, so the number in front of that is 5. And we don't have any other variables, so we can't have any more coefficients. So we only have one coefficient, and that's 5. The constant, do we have any terms here that are just numbers? Yeah, 13 is our number alone. It'll never change. Okay, and then for letter B, my coefficients, I'll put COE. What are the numbers in front of my variables? Well, in front of z, I have 2, and I have another variable, y. And what is the number that's in front of here? Well, you'll see that there's not a number in front of it, but how many y's, ask yourself this, are there? Well, there's just one y. So we assume that there is a 1 in front of it, okay, because there's just one y. So technically, you could put 1 for another coefficient. And then lastly, constants. Are there any just numbers in this problem, numbers that stand alone? Yep, it would be 3. Okay, so that's what you'll have to do first, is identify terms, coefficients, and constants in an algebraic expression. I've got 3 on your own to do that with. Please pause the video and try them out. Okay, so I'll do similar to what I did before. I'll list my terms, my coefficients, and my constants. Okay, terms in the first one, if I break it here, I've got 12 and I've got 10c. Terms in my second problem, I've got 15 and I've got 3w and I've got half. And lastly, I've got z squared as a term and 9z as another term, 2 terms here. You'll notice that I'm putting a slash through my z, and that's because if I didn't, sometimes it can look like a 2. So now that we're dealing with algebra, I like to do that. With my t's, I like to put a little tail on them because otherwise they can look like a plus sign. So I like to put a tail on them. My L's, I like to make a cursive L because otherwise it can look like a 1. So things that you kind of got to think about now that we're dealing with algebra. Let's go to coefficients. Again, the number in front of the variable. So here I've got 10. In my second problem, I've got 3 is a number that's in front of my variable. And in my last one, I have how many z squareds are there? Well, you can assume that there's a 1 in front of that, remember? So my coefficients would be 1, and 9 is also a coefficient. It's in front of my variable. And then lastly, with my terms, I'm just going to try to make this look like a little bit of a table here. With my constants, my numbers that stand alone, I've got 12 here. I've got 15 and a half in the second one. And in this one, I don't have any numbers alone, so I would just put none. Okay, so my time is dwindling down here. We'll pick up with example 2 in just a minute. Okay, picking up here with example 2, it says writing algebraic expressions using exponents. Write each expression using exponents. So remember that repeated multiplication you can write using exponents. So here I've got d times d times d times d. Well, there are 4 d's, so this would be the same thing as d to the 4th power. Okay. Sometimes students can get tricked on accidentally saying, "Oh yeah, there's 4 d's here. That's 4d." No, remember that this would imply multiplication, and multiplication is repeated addition. So this would be d plus d plus d plus d, different than times d. So try to make sure you're paying close attention to whether it's repeated addition or repeated multiplication. In the next one, I've got 1.5 times h times h times h. Okay, well, 1.5 times h I can just write as 1.5 and h right next to each other. If you remember, this implies multiplication. And how many times am I multiplying h? Well, there are 3 of them here. So 1.5h to the 3rd power. All right, go ahead and pause the video and try 4 and 5 on your own. Hopefully you came up with j to the 6th power here. And for number 5, you came up with 9 times k to the 5th power. Okay. Moving on to example 3, now we're starting to evaluate expressions when we know the value of these variables. So here it says evaluate the expression k plus 10 when k is equal to 25. So what I'm going to do is I'm going to substitute my known quantity of 25 in for k. It's telling me instead of writing k, I know that k is 25. So I'll rewrite this as 25 plus 10, which would give me 35. And similar for letter B, it says evaluate 4 times n when n is equal to 12. Okay, so I'll just substitute my value of n into my original expression. 4 times, and instead of writing n this time, I'll substitute the value of what I know n to be, which is 12. And 4 times 12 would give me 48. All right. Go ahead and try 6 and 7 on your own, just like that. All right. For 6, hopefully you came up with 33. 24 plus 9 would give you 33. And number 7, 13. 30 minus 17 is 13. All right. Example 4 says evaluate an expression with 2 variables. So we're doing what we just did, except now you're substituting in 2 different values. A divided by B. Okay, I know that A is 16 divided by B, which is 2/3. Okay, remember dividing fractions, you can make your first number of fraction by putting a 1 under it. And then if you remember to divide fractions, use the acronym KFF, can be helpful. Keep, flip, flop. So this is the same thing as 16 over 1. Flip your division to multiplication and flop this to its reciprocal. So this would be the same thing as 3 halves. The reciprocal of 2/3 would be 3 halves. Simplify before you multiply, so divide each one of these by 2. And on top, we'd have 8 times 3, which is 24, over 1 times 1 on the bottom, which is 1. Anything over itself is itself. So we'd get a total of 24. Again, pause and try 8 through 11 on your own. Okay, for 8, you should have got 3. 9 is 32. 10 is 16. And 11 is 192. If you need any help, please let me know. Lastly, moving on to example 5, where it says evaluating expressions with 2 operations now. So remember, order of operations will come into play here. You have to remember what you need to do first to do your math correctly. Evaluate 3 times x minus 14 when x is equal to 5. All right, I'll substitute 5 into this expression. So I have 3 times 5 minus 14. I have to do my multiplication first. If I'm following the correct order of operations, this gives me 15 minus 14, which would be 1. All right, and the next one, evaluate z squared plus 8.5 when z is equal to 2. So I will substitute 2 in to my expression, 2 squared plus 8.5. Well, 2 squared is 4. 4 plus 8 would be 12, plus another half would give me 12 and a half, 12.5. All right, pause, try the last 4 on your own. All right, hopefully for 12 you came up with 31, 13 is 26, 14 is 29, and lastly 15 is 37.5. If you have any questions on those, come see me or ask a friend. And that's all I have for this section. Hopefully this was a light introduction to algebra, and evaluating these expressions are going to come easier to you the more you practice them. All right. Until next time, 6th grade, we'll talk to you later.